All right, we're back to recording. So I need to. Back in. All right. Recording started. I think we're good to go. Cable trays. So you guys will mess with cable trays. We talked about cable trays a little bit. This is pretty much like I talked about in electrical one. Like we didn't talk about cable trays too much, but these are pretty much showing my age. But like if you've ever messed with an erector set or something like that, it's just a big structure that you can connect different pieces together, do what you want. Like there's no like bending or anything like that. Like you have straight pieces, you have elbows, T's, uprights, dropouts. And some of these are important because you can't just in order, like if you're using a cable tray for a piece of equipment or something like that, you can't just pull the cable out of the side and go hook it up because that's going to cause issues. Like you have to have certain, like NEC provides certain rules for making sure that you're doing stuff correctly and there's not any kind of, like if there's any kind of vibration, you're not cutting into the side of wires and stuff like that. So most of your tray terms are talking about the different types of pieces for cable tray components. So these are all the different ones. I don't have any highlights in the trade terms. My first highlight is the second sentence on the page. NEC Article 392 covers cable tray installations along with the types of conductors to be used in various systems. Article 392, you'll be looking that one up a lot, probably next time you guys are here, but that's an important one. Third paragraph, third sentence is highlighted. Non-metallic trays are also available. This type of tray is ideally suited for corrosive areas and areas requiring voltage isolation. Page 2. First sentence on page 2 is an online test question. Ladder tray, as the name implies, consists of two parallel channels connected by rungs, similar in appearance to a conventional straight or extension ladder. So that's like the main part of a cable tray. Looks like a ladder, a straight ladder laying down horizontal. That's all they're saying. You're going to have you're gonna have 4 questions come out of that figure 1 at the bottom of page 2. There's just a bunch of different types of parts and pieces and stuff, and they're gonna ask. Let me see. Yeah, they're just gonna talk about different sections of cable tray, and you just need to be able to identify them by how they look and stuff like that. But you'll have 4 questions that come off of figure 1 on page 2. Page 3, cable entry and exit. So like I said, it is important that you enter and exit cable trays in certain ways. My highlight on page 3 is the second paragraph. Most of the paragraph, first 3 sentences, I think. Several different ways in which cables may exit from a cable tray are shown in figure 6. While all these methods are NEC approved and endorsed by most cable tray manufacturers, the engineering specifications on some projects may prohibit the use of some of these methods. Key in on this next sentence. Most notable are the dropout between rungs method and the dropout from the end of the tray method. So if you flip over, let's say figure 4, figure 6. So 2 pages, geez, 3 pages from now, if you flip over to page 8 or look up on the board, y'all can see that. I'll flip back to the pages, but you can see the different ways that cable can leave or enter a tray. Some of them are, some you can do, like all of those are NEC approved, but you just have to make sure that, that whatever job you're doing, that they're also approved for that job. Is all that's saying. So pages 4 and 5 are just pictures and figures. Yeah, don't have anything on pages 4 and 5. Page 6. No, page 7. Still talking about entering and exiting a cable tray on page 7. The last paragraph before 112, the first sentence is one highlight. A dropout plate provides a curved surface for the cable to follow as it passes from the tray, as shown in figure 7A. And then the next immediate next sentence is a separate highlight. Without a dropout plate, cables can be bent sharply, causing damage to the insulation, as shown in figure 7B. Cable tray covers, 112. A first sentence and first bullet point are highlighted. A cable tray cover is used primarily for 2 reasons. Protect the insulation of the cables against damage that might be caused if an object were to fall in the tray, prime hazards or tools, discarded cigarettes, and weld splatter. So if you're ever anywhere where, like, have a cable tray where they're welding or something like that, you do not want weld falling onto cable trays. I will tell you, after climbing through a bunch of cable trays, there are a ton of cigarette butts. Even though it's a ladder, like, there's cigarette butts everywhere in cable trays for whatever reason. But yeah, definitely, like, obviously flicking a lit cigarette into a cable tray might, especially if you look on page 6, like the wires can fill up a cable tray and provide a landing platform for anything. So you don't want to drop anything into a cable tray that shouldn't be there. 113, cable supports in vertical trays. So these are trays that run vertically up the walls. So like the picture on the board or picture on page 9. 113, cable tray supports in vertical trays. First sentence is highlighted. A cable hanger or elbow is used to suspend cables in long vertical runs. So that's just the vertical elbow is just like you're dropping, or you're going from horizontal to vertical. The rest of that paragraph is a separate highlight. Care should be taken to ensure that the weight of the suspended length of cable does not exceed the cable's manufacturer recommendation for maximum allowable tension of the cable. You're gonna have to make sure that those cables are supported every so often, because if you think about a cable, some cables weigh 1 pound per foot. If you're dropping 3 stories, that's going to be 30 feet. You're going to have quite a bit of weight on that cable tray, especially if you're doing more than 1 wire. So you want to make sure to strap those off to the cable trays. Splice plates, 115, last paragraph on the page, into the next page is highlighted. Vertical adjustment splice plates. Vertical adjustment splice plates are used to change the elevation in a run of cable tray. They should not, going on to page 9, they should not be used where it is important to maintain bending radius. Vertical adjustment splice plates are useful when the change in elevation is so slight or the angle is so unusual that it would not be possible to install a standard outside vertical riser elbow or an inside vertical riser elbow in the space available. So you can see it's like an offset in a tray. In figure 9 shows that on page 10. I don't know that I have, or on the board. I've got it on the board. If you can see that, it's another piece of that erector set that you have a swivel plate that you can move to where you want it, and then you tighten it down, and that provides for a run or a rise in elevation. Whereas you wouldn't want to do like a back-to-back elbow. barrier strips, 116 on page 9. First sentence of barrier strips are used. Barrier or divider strips are used to separate certain types of cable as a result of the nature of installation, types of circuits used, type of equipment used, local codes, or NEC. Like I've talked about before, and like we'll talk about whenever we get to instrumentation. If you have large power cables running through a cable tray, you cannot put instrumentation wiring next to those. Because of electromagnetic interference, the electromagnetic interference that any wire with current flowing through it puts off, you don't want that to mess with like 4 to 20 milliamp signals or very small signals, or voltage signals for instrumentation or signal cabling or even Ethernet. So they have what's called a barrier strip, which is literally just a piece of metal that goes in between stuff in a cable tray. Cable tray supports, this is a big one, 120, flipping over to page 10 and 11. You have different types of cable tray suspension, which we talked about, and I think we talked about in electrical 1. So we have I'm on page 11, 121 direct rod suspension. First sentence is highlighted. The direct rod suspension method of supporting cable tray uses threaded rods and hanger clamps. Wall mounting, 122. The sentence that starts, second sentence that starts on the left and ends on the right. This method for wall mounting, this method of support is often used in tunnels, mining operations, and other ungrounded or sheltered installations where large number of conductors, interconnected equipment that is separated by long distances. So if you are in a tunnel, you are using wall mounting. Again, that was at some point while I'm teaching, that's been a highly missed question for whatever reason. So make sure you have that one. Trapeze mounting, so you can see trapeze mounting and direct rod suspension look similar, but just notice that the trapeze mounting uses a piece of C-channel, so it's able to hold more. C-channel or unistrut can hold more weight than direct rod suspension. No highlights in trapeze mounting. Moving on to page 12. And I wish page 12, I've never worked anywhere where the cables look that nice in a cable tray. That's a new installation. It looks like a very clean facility. Page 12, you got center hung support, pipe rack mounting. I expect another online test question you guys to have to come from one of those, but I don't have highlights in those. The monorail system is shown in figure 13. So that's the one that's on the board, or figure 13 on page 12. I do have the second sentence of 126 highlighted. Center rail cable is used for light duty applications such as sound, telephone, and other communication systems. I've used these. I've run Ethernet in these before. They're super easy to install as well as run cables in. So that's section 1. You got section review 1 on page 13. I'm going to continue on to section 2. Let me section 2, cable tray loading. So obviously you can't just put anything you want in these cable trays, especially certain types of cable trays are prone to not a lot of weight. And it can also, like packing cables together, can also cause more attenuation in the cable or loss of signal. First paragraph, last sentence on page 14 is highlighted. Cables packed closely together can reduce the efficiency of the conductors. So cables packed closely together can reduce the efficiency of the conductors. 210, determining the load on supports. That first sentence, you're going to have a couple questions come out of that first sentence in 210. Each support should be capable of safely supporting approximately 1.25 times the full weight of the cable and the tray on a typical span as shown in figure 15. (1.2 times the full weight of the cable). 220, failure under load. So you can see failure before it's a major failure. So you can see these failures before they happen. You need to know the two different types of failures, and the highlights I have for those are I'm in a class. The two highlights I have for those in 220, failure under load. What is it? 1, 2, 3, fourth sentence is highlighted. The traverse failure, traverse or rung failure occur when the load applied causes the fibers on the tension side or the bottom edge of the rung to stretch and permanently deform. Skip a sentence, and I've got the longitudinal or side rail failures sentence highlighted. So longitudinal or side rail failures occur either as bending failures when the tray is supported on a larger span, or on longer spans, buckling failures may occur because the side rails of the tray have little resistance to inward or outward movement. Show pictures of those. Those are I don't know. Make sure you know the difference between traverse failure and longitudinal failure. I wish they showed pictures of those. It's confusing. Nothing on page 15. Going on to page 16, 230, installation requirements. Cable tray drawings on page 16, 231. I've got the sentence in the top right of the page highlighted. The exact method of showing cable tray systems on working drawings will vary, so always consult the symbols list and legend before beginning installation. Got NEC regulations governing the use of cable trays on page 17. I've got 3 highlights from that figure 18. I've got the one that says NEC section 392.10B1A, close to the top left, highlighted where conductors number 1/0 through 4/0 are run in ladder type trays. The maximum rung spacing must not exceed 9 inches. So you can't have more than 9 inches, as you can see in the picture, between your rungs. The center middle, the most middle note I have highlighted. Non-metallic cable tray is permitted for use in corrosive areas and in areas requiring voltage isolation. That's NEC section 392.10D. And then the one furthest to the bottom is highlighted. Electrical conductors must not be installed in the same raceways or cable trays with steam, water, gas, air, or drainage pipes. You cannot have steam, gas, water, air, or drainage pipes in a cable tray with electrical line for obvious reasons. Page 18. They've got even more NEC, like you can see all the different types of NEC articles that govern cable trays. These are a big thing. The one I have highlighted on page 18 is the one in the bottom left, where multi-conductor cables operating at 1,000 volts or more are installed in the same cable tray with conductors operating at 1,000 volts or less. The two types of conductors must be separated by a solid fixed barrier of metal compatible with the cable tray unless the cable is over 1,000 volts or type MC. So that's type, if they're 1,000, I've never seen a metal clad cable over 1,000 volts, but that's MC cable is metal clad cable, which would have its own cover, but you can see the barrier plate in that bottom left pictorial to separate cables over 1,000, cables under 1,000. Page 19, figure 20, even more highlights. The one center right is highlighted. Proper grounding lessens hazards due to ground faults. Therefore, NEC requires all metal cable trays to be grounded as required for conductor enclosures in accordance with NEC section 250.96. You have to ground your cable trays. You do not want those to become electrified. Bad day for somebody. And then the note all the way in the bottom right, or the NEC 250.96 one is highlighted, the little short one. Cable tray sections and fittings must be bonded in accordance with NEC 250.96. So they just must be electrically connected so that they are grounded together. You can't just go by the metal connections themselves. They must have like an actual electrical bonding wire connecting the two pieces together. Bottom left of page 19, the paragraph in the bottom left, online test question is the first sentence. In actual practice, however, consulting engineering firms seldom furnish the isometric drawing. They merely show the layout in a plan view. In actual practice, however, consulting engineering firms seldom furnish the isometric drawing. They merely show the layout in a plan view. That's all I've got for section 2. We've got section 2 questions on page 21. I'm going to move right in to the super long section 3. Section 3, cable tray fill. Just the same thing as loading. Like you can only fill up these cable trays so much, and there's a lot of rules. NEC has a lot of rules on your fill capacity. First paragraph, second sentence is highlighted. For example, cable splices are permitted in cable trays provided that they are made and insulated by NEC approved methods. So you can splice in a cable tray, but you have to do it by the NEC standards. I wouldn't, unless it's like the last ditch effort or a temporary thing, I would not make splices inside of a cable tray because it's bound to happen where my big butt is crawling through the cable tray and I kick that and mess up your splice. Unless it's like a temporary or very well done thing, I would not make splices in cable trays personally. It is allowed. 310 or 311, conductor sizes 4/0 or larger. That the first sentence of 311 is going to have 2 practice test questions and a section review question come from it. So these are conductor sizes 4/0 or larger per NEC section 392.22A1A. Where all of the cables installed in a ladder or ventilated through tray are 4/0 or larger, the sum, key in on this, the sum of the diameters of all cables shall not exceed the cable tray width, and the cables must be installed in a single layer. You cannot layer cables that are 4/0 or larger. They go through talking about conductors that are smaller than 4/0. I don't have anything in section 312. I don't have anything on page. They do math on how to figure out how much fill you can have and stuff like that. I don't have any highlights on that, but you guys, you can feel free to read through that math if you want to for conductor fill for conductors smaller than 4/0. Combination cables. These are going to be a lot of instrumentation cables. Some electrical stuff has combination cables. I don't have anything on page 23 or even in that section. But if you flip over to page 24 and 25, I think the picture that's on the board, or that picture in the bottom right of page 24, that's my favorite picture that I've seen in CCR. Like, I don't know if that's real, but I don't know how they put those wires in there. Like, there's no way that that's real. Like, I don't know how you pull that through a cable tray. If it is real, like, that's amazing. Like, that's amazing that they could do that. But there's probably an OSHA person crapping their pants if they see that somewhere. I don't have anything on 24. Page 25, I picked back up in 320. Ampacity of cable tray conductors. I've got 3 different questions that come out of that first paragraph. First sentence is one highlight. NEC section 392.80 gives the requirements for cables used in tray systems with rated voltages of 2,000 or less. The next sentence, you're going to have a practice test question and a section review question come out of. Cables and cable tray use the same ampacity tables as other cable, with additional D rating applied for the following conditions. I've got the first bullet point highlighted. Cable tray construction. Cable tray can be open or covered and solid or ventilated. Covered, unventilated tray is subject to ampacity adjustment. Out to the side I wrote, uncovered is not. If you cover up a cable tray and you have wires inside of it, that cover holds that electromagnetic interference inside of it, so it has more D rating factors that have to happen because it's holding everything on the inside. So where you don't have to have covers, don't have covers. But if you need a cover, just know that there might be some type of D rating that has to happen if you have enough power cables going through there. All right, guys, that's all I got. I'm gonna stop the recording.